Hello, another AQA Physics multi-choice question. You could choose a different one by clicking on the information card here, or you could try this one now and pause the video. If you got an answer of A, well done. Here's my explanation. A pellet with a velocity of 200 meters per second and mass 50 grams is fired vertically upwards into a stationary block of mass 95 grams. The pellet remains in the block. The impact causes the block to move vertically upwards. What is the maximum vertical displacement of the block? So what we've got is, we've got a bullet, and that's moving upwards, and it's going to hit this block of wood, get embedded in the block of wood, and then together they'll move up together. So perhaps the first thing we could do is we could find out how fast this block of wood's moving at, and we can use the idea of conservation of momentum. So we know the momentum of the bullet is going to equal the momentum of the bullet and the block together. So the momentum is given by mass times velocity. So the momentum of the bullet, its mass is 0.005 kilograms multiplied by 200 meters per second, and that's going to give me a momentum of 1 kilogram meter per second, and that's also going to be the momentum of the bullet and the block together. So let's find the velocity of the bullet and block together, and we can say that the velocity is equal to the momentum over the mass. I've just rearranged this equation. We've already said the momentum is conserved, and it's 1 kilogram meter per second. So it's the block of wood and the bullet together now, and those masses added together add up to 100 grams or 0.1 kilograms, and that is 10 meters per second. So that's the velocity of the block with the bullet in it, 10 meters per second. Now I need to find a suitable Suvat equation to find how high up that block is going to move. So I'm going to use the equation final velocity squared equals initial velocity squared minus 2 times the acceleration and the distance. And I'm going to rearrange this equation to make the distance the subject, and that distance will be the height. I'm going to completely ignore this term final velocity squared, because the final velocity squared is going to be 0, because when the block goes up, it'll have a velocity of 0 before it starts coming down. Okay, so let's rearrange this equation. The distance is going to be equal to minus u squared over 2a. I'm keeping the signs correct all the time, and I'll show you why in a second. So the initial velocity we just worked out was 10 meters per second, and I'm going to take the minus of that value, and I'm going to divide it 2 times the acceleration. Now the acceleration is 9.81 meters per second squared. This is happening on Earth, but it's actually accelerating downwards even while it's traveling upwards. It's accelerating downwards because it's slowing down. So I'm going to put it's 2 times minus 9.81. And if you look, when I do all this multiplication and division, these minus signs are going to cancel and we'll end up with a positive upward displacement. If I put those numbers into my calculator, I get an answer of 5.1 meters, which is answer A. If you found this a useful video, hit that subscribe button please. Press the like button, share with your friends, and watch more of them in the series. Thank you for watching.